Okay, so today we are going to start solving systems algebraically. If you noticed in your homework last night, or yeah, your homework last night on the half worksheet, the last problem had two answers. I'm going to skip that for a minute. This worksheet, this number 8 had two answers. One of them was at 0, 7. I'm just going to kind of quick sketch this. And you had a line that looked something like this. This is going to be really rough. And then this parabola, you were at 1 and you were at 7. And you ended up having a vertex. Your x coordinate would have been 4. And your x, I'm sorry, your y should have been -9. So you had something like this. So one of your answers was 0, 7, but then if you notice, there's a second answer because these, if you were to continue this graph, would connect again up here. So that's where your second answer comes from. So obviously in a 10 by 10 graph, it's going to get kind of messy and difficult to be accurate with your answers. So today we're going to talk about solving them algebraically, because sometimes, like in this case, your graphic way of solving it is not the best way. So we're going to do this warm up, and you guys can do it at the beginning of your notes, which should be, I think, it's page 213. Let me double check with kind of where we're at. Sorry, I didn't put a page number on this. 213. So 212 should be blank. So on page 212, I want you to go ahead and this is a math 1 concept. So what you should really be able to do right now is write down this problem, hit pause, and then work through the problem, and then hit play again and see if I did it correctly. So what you're going to do is it says solve the system using substitution, which means we have an x equals and then another equation. I am going to take this 2y minus 3 and I'm going to substitute it in for x. So I have 3 times 2y minus 3 minus 5y equals 12. So then make sure you put that in parentheses, otherwise you're going to have issues. You get 6y minus 9 minus 5y equals 12. So when we combine like terms, we end up with 6y minus 5y, which is y minus 9. And then when you add 9 to both sides, you end up with 21. So y is 21. So then you're going to take that value and say, okay, well, if y is 21, I know x is 2y minus 3. So now I know x is 2 times 21 minus 3. So 42 minus 3 gets you 39. Now remember, when you're solving, we just did this graphically. So what you really just solved for was a coordinate point. I will take off points if you do not write it as a coordinate point. You have to write it as 39, 21. That is where those two graphs meet, which makes sense. This is linear, this is linear. They're going to meet in one point. Okay, so now I want you to go ahead with that same idea and turn to page 213. And you'll see the warm-up. So it says a plane flies 900 miles in 3 hours with a tailwind. It takes the same plane 5 hours to fly 900 miles with a headwind. So either the wind is helping or it's hurting their speed. So then they give you a system of equations right here that expresses the distance of the plane. And they're saying r is the speed of the plane in still air and w is the speed of the wind. So it says use substitution to solve the system of equations. Well, if you look at that, when in the warm-up problem, we had one of these solved for. In this problem, you do not have a variable already by itself, so you're going to have to do that. Now, it does not matter which one you pick. I'm just going to pick this top equation. The 900 equals r plus w times 3. And I'm going to take that and I'm going to solve for one of the variables. It doesn't matter which one. I'm going to divide by 3 on both sides, and you get 300 equals, those cancel, so you're left with r plus w. And then I'm just going to subtract w to keep the r positive. So you get 300 minus w equals r. So now what I can do is I can say, okay, well, I know r is 300 minus w. I'm going to take that and substitute it into the other equation. You have to substitute it into the other equation or it won't work out. And say 900 equals r, which I'm going to rewrite as 300 minus w times 5. So if you clean that up, you get 900 equals 300 minus 2w when you drop the parentheses and clean it up, times 5. Divide both sides by 5. And when you take 900 and divide it by 5, you get 180 equals 300 minus 2w. Obviously subtract 300 to the other side and you get negative 120 equals negative 2w. And then when you divide by negative 2, you get 60 to be w. So if 60 is w, that's part of my answer. I'm going to use it over here to find out what r is, because I said 300 minus w is the same thing as r. So now 300 minus 60 equals r, so that's 240 is r. Sorry. Okay, so number 2 says explain the solutions. Well, it said r is the speed of the plane in still air and w is the wind. So what that means is in still air, sorry you guys, you know how annoying my computer is. In still air, the plane flies at 240 miles per hour, and the wind is blowing at 60 miles per hour. So that's why you see the difference in time in the original problem, because the plane is attempting to fly 240 miles per hour. Well, if it's flying into the wind, it's going to get pushed back a little and fly slower, hence take longer to go to the same amount of time. If it's flying with the wind, obviously, then it's going 240, but the wind will help and it'll go a little faster, and that's why you get there in less time. Okay. All right, so go ahead and turn your books to page 215. We're going to look at example number 1. Now, in example number 1, this is slightly different than our warm-up because it says solve the given systems of equations algebraically, and they're both solved for y. In our warm-up, only one was solved, and it was for x, but only one of our variables were alone. But since both equations are equal to y, all we're going to do is take one of them and sub it in for the other y. So that's going to look like negative 3x plus 12 equals whatever this is, there we go, x squared minus 11x plus 28. Now we know how to solve that. That's quadratic. You need to get everything to one side and solve. So I'm going to add 3x over, right, because one side has to be 0, and subtract 12, and you're going to get 0 equals x squared minus 8x. 28 minus 12 is a positive 16. So then we have a quadratic. We have multiple ways of solving that, which we all know. We can factor it, quadratic formula, complete the square. We cannot solve by square roots here because we have the x term. I'm going to factor it. You can solve it by quadratic formula. It doesn't matter. I'm sorry, I'm doing step 2. You know how this book is. So x and x. Two numbers that multiply to be 16 and add to be negative 8 are negative 4 and negative 4. So we're going to get the same x value no matter what. If we set x minus 4 equal to 0, we get 4. You don't need to do that again. Over here it's redundant. You're going to get the same answer, but that's not the whole problem. We need to know what y is. So you need to go through and say, okay, well, I know that we're not going to do that part, sorry. So I know that x is 4. It does not matter which one you pick to sub it back in. I'm going to pick this one down here because it's easier. It's linear. I'd have to do less work. That means y equals negative 3 times 4 plus 12. So y equals negative 12 plus 12. So y is 0. So your actual answer you're going to write as 4 comma 0. We're not going to graph these. If you were to graph them, you would just find their intersection point like yesterday at 4 comma 0. So they would both end up right there. All right. So on to example number 2. Example number 2 is the exact same thing as example number 1. So it might be in your best interest to pause the video, work it out, and then listen to me work through it so you can check your work and see if you were correct. So I'm going to take this x minus 1 because they're both solved for y, and I'm going to sub it in up here. And I have x minus 1 equals 2x squared plus 13x plus 15. Get everything to one side, so subtract x. I'm going to add 1. I get 0 equals 2x squared. Sorry, that's a squared. 13 minus 1 is a positive 12x, and then plus 16. I look at this and I say to myself, this is divisible by 2, this is divisible by 2, and so is that. So I'm going to factor out a 2 and be left with x squared plus 6x plus 8. And then that is factorable from there. X and x. Two numbers that multiply to be 8 that add to be 6 are positive 4 and positive 2. So when you solve for x, right, if we set 0 equal to 2, that doesn't help me. 0 equals x plus 4. That tells me that x should be negative 4 when I solve. And x plus 2 equals 0, so x is negative 2. Okay, but again, I have two x's. I need their corresponding y's. So I'm going to use the easier equation to solve for y. It doesn't matter, but why not do the easier one when you can? So here, y is going to be negative 4 minus 1, which is negative 5. And here, y is going to be negative 2 minus 1, so negative 3. So your actual answer should be negative 4, negative 5, that's one coordinate, and negative 2, negative 3. That's your answer. Make sure that you don't get sloppy and put negative 4 with negative 3 and negative 2 with negative 5. That happens a lot. Okay. All right, so we're going to take that. Let's see if I can do this without my mouse. Okay, so now we're going to do the same thing with example number 3. It's literally the same setup as the first two, so the process shouldn't be difficult. Again, if you want to pause and then check, that's fine. The answer here is a little different. So we end up with negative 3x minus 30 equals 7x squared minus 25x minus 12. Going to bring everything over to one side. So we have 0 equals 7x squared minus 22x plus 18. So I look at this. I could try factoring it. This would be 7 and 1. I have a few options for 18. It's not wrong to try and factor it. I know in this case it's not factorable. And here I could kind of tell up in this problem that this part was easily factorable, which is why I went with factoring. So if you can't see it quickly, I'm going to move on to quadratic formula. I'm not going to complete the square here. There's no way with that 7 and 22 I'm going to try and make that happen. So we have x equals, maybe, the opposite of b, plus or minus square root of b squared minus 4 times a times c all over 2 times a. So if you clean that up, you end up with 22 plus or minus the square root of negative 20 all over 14. So we know this negative here is going to come out, And your answer is going to be 22 plus or minus I radical 20, which isn't pretty, so leave it as radical 20 all over 14. So that's x. Now, if you think about it, we're looking for these intersection points. This, on the graph, we didn't do it graphically, but had we would have hit those two intersection points. When you're graphing, you're only graphing in the real number system right now. So this I tells me that I'm going to end up in the imaginaries. So there is not going to be an intersection, and it's no real solution. So as soon as you see an imaginary number, it's no real solutions, because technically, I'll write it over here, your graphs will never intersect. That's what that means. So there is no system, there is no solution, because remember, when you're finding a solution to a system, you're essentially finding the point on the graph that they intersect. So that's never going to happen here. Now, we're going to talk about that a little more with example number 4, because with example number 4, they give you this graph, and it says, given the graph of the system of equations below, determine algebraically the solutions to the system and explain the meaning of the solution in terms of the graph. So they gave you both things. They're giving you this system, and they're giving you the graph. So based on the last problem, we should be able to look at this graph and say, okay, these never intersect. The circle and the line never intersect, so we have no real solution. Now we're going to do the algebra behind it and prove why it's no real solution. So I'm going to go back to the system. Here, one of my variables is solved for, so I'm going to take that x minus 5 and I'm going to sub it in for y down here. And I have x squared plus x minus 5 squared equals 9. So this is really x squared plus x minus 5 times x minus 5 equals 9. Multiply out your parentheses, and we get x squared plus x squared negative 5x minus 5x is negative 10x plus 25 equals 9. So x squared plus x squared minus 10x plus 25 equals 9. So we get 2x squared minus 10x plus 25 equals 9. So one side has to be 0, so subtract your 9 over, and you get 2x squared minus 10x. 25 minus 9 is a positive 16, so we get 0. Okay. Here at this point, I would actually try factoring that. However, I'm given the picture. I know it's no real solution, so in my brain I'm going to say, no, just kidding. I'm actually not going to factor that because I know it's not going to be factorable because it's no real solution. I'm going to go straight to quadratic formula. You could also complete the square, but quadratic seems to be the most reliable. So we have opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we end up with 10 plus or minus the square root of negative 28 all over 4. So 10 plus or minus I radical 28 all over 4. So this I that happens right here tells me, okay, I have an imaginary answer. That's why there's no real solution. That's why my graph never intersects right here. There's all that space between. So that's how the graph is connected to the algebra. If you're doing it algebraically and you come up with an imaginary answer, that means if you were to graph those 2 or 3 or however many, I mean, we're going to focus on 2, but the lines would never intersect with the graphs. Okay. All right, go ahead and turn to the next page. We're going to look at the PBT. This PBT is not difficult. However, it does take some detail. So if you're writing sloppy, you're going to want to slow down big time here and make sure that you're paying attention to each step and you're not losing anything because of the numbers they give you. So it says that you have a fictional bike company for your business science class. Nico determines through research that the marginal cost of producing a bike is this. Okay, and that is the C, so your Y is the marginal cost in dollars per X bikes produced. So X is your bikes produced, Y is your cost. Okay. Fleur determines that the marginal cost for manufacturing her bikes could be modeled by this. Assuming each student's fictional company starts manufacturing bikes at the same time, at what marginal cost will each company have manufactured the same number of bikes? So we're looking for when this equation equals this equation, because we want to know when our x's are going to be the same. So I'm going to take C1 and set it equal to C2 because I want to see when they're the same. So this is what I mean. If you look at all these decimals, C1 is 0.0005x squared plus 0.07x plus 50. Sorry, I literally have no idea where that blue is coming from. And set that equal to 2/5 x plus 62.5. Now, I'm going to do something here because I notice I have all decimals except for this 2/5. So I'm actually going to take that 2/5 and I'm going to rewrite it as its decimal equivalent. And 2 divided by 5 is 0.4, because at least now you're dealing with all decimals and you're not going back and forth between the two. Well, similar to our last problems, we need one side to equal 0. So I'm going to subtract 0.4x. And I'm going to subtract 62.5. So we have 0.0005x squared. 0.07 minus 0.4 gets you negative 0.33, so negative 0.33x. And then obviously 50 minus 62.5 is negative 12.5. These all cancel, so then we have 0. So I look at that and think, there is no way I'm going to try factoring that. I'm going straight to quadratic formula. Even though the numbers are ugly, then I can rely on my calculator. So we have x equals the opposite of b, so a positive 0.33 plus or minus the square root of negative 0.33 squared minus 4 times 0.0005, that's your A, times negative 12.5 is your C, all over 2 times 0.0005. So watch it here, you guys, because there's so many zeros, you can definitely get lost. I'm going to calculate my discriminant first. If you put that in your calculator as is and very carefully, you're going to get 0.1339. So this works out to be x equals 0.33 plus or minus the square root of 0.1339 all over, your denominator ends up being 0.001. So we need an actual number. We can't leave it like that. So in our calculators, we need to separate this out and do 0.33 plus the square root of 0.1339 all over 0.001, and obviously then do it with minus. When you do that, the two answers you should get are 695.92 and negative 35.92. Well, if you think about what x represented, x was the number of bikes. You're not going to make negative 35.92 bikes, so you can get rid of that, and you can focus on the 695.92. The question is asking, at what marginal cost? Well, cost was y. So I need to take this x and I need to go back and solve for y. And I'm going to use C2 to do that because it's the easier equation. The 2/5 times 695.92 plus 62.5. Now, when you do that in your calculator, I'm going to calculate mine quickly. You get, y to be 340.87. So the question is saying at what marginal cost will each company have manufactured the same amount of bikes? It's a cost, so that's a dollar amount. At $340.87 is where they will be the same. Okay. All right, so we have 2 extra examples just to make sure we're good to go. You can do these on page 218. It should be blank. What I want you to do is to write them both down. I want you to hit pause, and then I want you to work through them and check your answers with the video when you're done. All right, so here you should take this -2 and sub it in, and we get -2 equals -2x squared plus 5x minus 2. So we're going to add 2 to both sides and get 0 equals -2x squared plus 5x. These end up canceling, so that's kind of nice because to solve this, I can take out an x. I'm actually going to take out a -x to make my life easy. And then I have 2x minus 5 left. So is that 0 equal to -x and 0 equal to 2x minus 5? This is an answer, you guys. You technically are dividing by -1 here. So you get 0 equals x, and then you get 5 equals 2x, and then divide both sides by 2, and you get 5/2 equals x. So you have your x's. The greatest part about this problem is no matter what your x is, guess what your y is? -2. So one of your answers is 0, -2, and your other answer is 5/2, -2. So 2 intersection points there, and both are y values of 2 because you would have a straight line. All right, for the other one, you're going to have to do a little bit more work here. So I'm going to still do the same idea of substitution and have x squared plus, now I have -2x minus 4 squared equals 32. Sorry, you guys, I have no idea what this blue is. Slightly annoying. Okay. You're going to have to multiply that out, and you get x squared plus -2x minus 4. That makes a big difference. And -2x minus 4 equals 32. So you end up with x squared plus 4x squared. +8 and +8 is a +16x, and then 4 times 4, they're negatives, but it'll be a positive, equals 32. So when you drop your parentheses and combine like terms, you get 5x squared plus 16x. This would just be 16, but you're going to subtract 32 to make that 0, so I did a couple steps in one there. So then I would look at that. I'm not really going to try and factor it. Just don't even want to waste my time. So let's use a different color so we don't run in. There we go. X equals the opposite of b, plus or minus. Do all your square root. And then you need to clean that up. And you get 576, so this totally would have factored. All over 10. That's just apparently being extra lazy. Because the square root of 576 is 24. So you have -16 plus or minus 24 over 10. So -16 plus 24 over 10 and -16 minus 24 over 10. So you get 4/5 over here, 4.8. And over here, you get -4. So now you need to take those, substitute them back in. Again, I'm going to use the easier one, the y equals -2x minus 4. So y equals -2 times 4/5 minus 4. And y equals -2. Now, -4 over here. Sorry, you guys, ignore all the blue. This is annoying. So you get -5.6 over here. And 4 over here. So your two intersection points are at 4/5 or 0.8, negative 5.6 or whatever the fractional equivalent is, and negative 4, 4. So that's one answer. That's another answer. This is something you would definitely want to do algebraically because you would never easily find this answer graphically. Okay. All right, so now you can go get your worksheet from the sub once you've shown that you've taken notes, and you can finish this worksheet. Whatever you don't finish today is homework over the weekend, and then on Monday you'll have a follow-up worksheet to work on as well. But this is the video for both days. I just combined them all. So from now on, it's just work time until Tuesday.